I want to begin by getting the hang time. And so what that means is the time that it spends in the air. So I'm going to take this initial velocity, v naught, launched at an angle theta. Now I'm not going to actually get number xy component. So what I could do is I could say, oh, v naught x is 5 cosine 30, and v naught y is 5 sine 30, and I could do all that. We're not going to do that. Instead, I want to actually do it using the letters only to get a general formula so that if I were to change the speed and the angle, I could just adapt and get the hang time no matter what numbers I'm given. So Vy is going to be V naught times the sine of theta, and this is the initial, and V naught x is going to be V naught times the cosine of theta. Now, the hang time only depends on my time in the air. So I have a formula I can use, which is Vy equals AT plus V initial y. And in this case, let's look at half the trip. So I go up vertically while traveling horizontally, of course. But here's the thing. At the top here, my Vy is 0. And so I know that at the top, 0 is my speed, and that's a known. And that's going to equal A times T plus, now my initial y speed is going to be V naught times the sine of theta. And I'm launching that in the air. We're going to say that up is positive, and that means down is negative. So my acceleration here is going to be negative g. So 0 is going to be negative g plus v naught times the sine of theta. And I need to put the t there for multiplication. So now what can happen here? Actually, t isn't known, so I need to write that in the proper unknown color. So t is an unknown variable. Everything else, like for example, I could put in 5 for v naught and 30 for sine theta and 10 for t and get 10 for g and solve for t. When I isolate t, I'm going to get that t is in terms of all given numbers. So in other words, I could put in 5, 30, and 10 and get t. Now this is actually half the time. This is the time up. The total time, t, the total hang time is going to actually be equal to v naught sine theta over g, and I need to multiply that by 2. All right, so that's the time it spends in the air. In the next video, we're actually going to go ahead and figure out what the maximum height is.